So this is a spectrophotometer.
And you're going to turn it on from the back. So this is how you turn on the instrument, and then this is how you're going to turn on the lamp. And you're going to come over here and you're going to see this light. When it's flickering, that means the lamp needs to warm up. And when it's solid, like it's shown here, that means the lamp is ready to use. So here we use a xenon arc lamp. And it has a white light which goes to a monochromator, which is right here. And that monochromator is going to be your excitation wavelength selector. And then it's going to come over here and it's going to go through a slit, which you'll set up on the computer. And then your sample goes right here. The detector is set at a 90-degree angle, and it'll actually go through another monochromator right here, which is going to be our emission wavelength selector. Then it'll go to our detector, and lastly, to our computer. The lamp can take anywhere from 15 to 30 minutes to warm up. During this time, you can prepare your sample. Once the lamp is warmed up, you're going to go ahead and log into the computer. To do this, you're going to look in the back of the Floormax book for the password. Once you are logged in, you're going to open the program by clicking the fluorescence icon. Once the software is open, you're going to go up to the M, and you're going to open the configuration. It is now going to initialize, and we have to wait for it to finish. Once this window pops up, you're going to select Spectra. You're going to select Emission. Once this window pops up, you will see an excitation and emission. This is going to be in reference to the monochromator that's in the instrument. For the sample that I'll be running today, I'll be keeping the 350 nanometer wavelength the same. But keep in mind that this wavelength can change based on the sample you will be running. Now we'll go to the slit. I'm going to change it to 1 nanometer. In order to figure out what wavelengths you will be using for the emission, the start will be 350 from the excitation plus 15. In this case, we don't have to change it. The end will be the excitation wavelength of 350 times 2, and then that number minus 15. In this case, it'll be 685. We'll also be changing the slit of the emission to 1 nanometer. Now we're going to go to the detectors. Here we want to make sure that both S1 and R1 are clicked. Now we're going to make an equation. Go down to the signal algebra and hit S1 minus R1 and add. This is going to be a corrected spectrum. Now we're going to get rid of S1, remove, R1, remove. Lastly, we're going to go over to the accumulations and select 3, and then change it to average scans. So before we hit run, we have to make sure that our sample's in there. So this is a 10 ppm quinine solution. And we're going to go ahead and take our cuvette and add our sample in. Now we have to make sure that our sample is about 85–95% full, since the light will be going through the center of our cuvette. After we fill it up, we want to make sure that we wipe the sides to make sure that nothing got on the sides, since the light will be going through here and we are measuring excitation and emission, and we don't want anything to affect our results. After we made our sample, we're going to go ahead and put it in the instrument. Now we can go ahead and run our sample. Since this is ran in triplicate, this will be shown 3 times. You can change this when setting your parameters. Once your sample is ran, this graph will pop up. Double-click on the graph, then go to Analysis. Calculate Integrate, then press OK. This will bring up a detailed information of your data. You can write these values down. Once your sample is done, go ahead and exit out of the software. Don't forget to take your cuvette out. And then you want to make sure that you turn off both the lamp and the instrument. When you go to open the software, if it does not open, you're going to have to restart the computer.
The Roy pro tip.
Remember, if you have any difficulties, please make sure to contact your UTA engineer. You don't want them to look like this.